Okay, so this video is going to be the third video in our vectors mini-series. I was almost going to say playthrough then. And we're going to look at geometric problems and just the pathfinding section of it. Not all of the super duper complicated stuff that comes after it. That'll be another time. So, how it's going to go is I'm kind of going to do a slide and then you're going to do a slide and we'll back and forth and etc. So, in this one, we want to write these four vectors. Remember, if we have two letters next to each other with a line on top, that means a vector. If it's just the two letters next to each other, that just means the length. So, we've been told that this vector here is u between a and b. Remember, with a vector, it is only just kind of the movement. It's not stuck to one position. So actually, this also is the vector u. And then when I write it, I always do an underline. They don't because they write it in bold. But with my handwriting and your handwriting, it's hard or impossible to indicate what bold is, so we underline it when we draw it on paper. So you could be that. You could be this vector here. You could be this vector here. U is just representing as going one kind of block to the right. So if we wanted to find the vector JL, well, here's J, that's my starting point, and this is my ending point. So if I go one block to the right, that's U, but I need to go another block to the right, so that is also U. So this full vector here would be 2U. I'm doing two lots of the movement that U is. Okay, how about RQ? Well, R is here, and Q is just to the left of it. Well, U is telling me to go one block to the right. So if I actually go one block to the left, that would be minus U, because I'm doing the opposite of what the positive U is. So that would just be minus U, and just one of them. Pn. Let's have a go at finding where P is and where N is. So this is my starting point. You always start on the first letter and then end at the second. So if I go back one block, we've said before that's going to be minus U, and I need to go back another block. So the answer to this would be minus 2U. I've gone to the left 2 blocks. And then EH. So E to H. So I'm going to go across one block. I've already drawn this one on. That would be my second. So that would be 2U so far to get from E to G. But from E to H, it's going to be a third one. So that will be 3U. Okay, on this next slide, would you be able to have a go at the ones down here? So what we're told is that A to I, so kind of 2 blocks upwards, it's a bit slanted but it's just kind of going up in our diagram, is going to be the vector V. So you need to find CS, PH, RN and FR. I'm going to go through the answers in a couple seconds. Okay, hopefully you've had a good go at them, and let's have a go through. So C to S, that's going to be from here to here. So V would be this, that is V, but I need to go another lot of that, another 2 blocks up. V, so this would be 2V. How about PH? So P to H, I'm going down by 2 blocks. So that would be negative V, because I'm going in the opposite direction to what V is telling me to go in. V is telling me to go up, I'm going down by the same amount. R to N. Well, I'm going down, so I know it's going to be a minus. But if I was doing a minus V, I'd have gone down 2 blocks. I've only gone down 1. So I've actually done a half of that movement. So that would be minus a half V. You could also write that as minus 0.5 V. But fractions are always the best when we're doing vectors because it just keeps it neat and tidy. And then F to R. So I'm going to do this in a different colour just because I'm going to overlap. Nope, I'm already on pen. I want pen colour. I'll do this in a blue. So F to R. So I'm going to go up a full V, which is this. And I'm going to go a little bit just to the side of it so I don't cover that up. And then my movement on just one block is half V, because I'm just doing half of this movement of a double block jump. So I've done a full one and a half one. So I've done 1.5 V, or you can write that as 3/2V, and you could also write it as 1.5, but I'm not going to do that because I don't like it. So well done if you got them right. And if you understand them now, that's just as good. So this one, that was just all kind of one direction movement, but ideally we're going to want to kind of combine left and rights and ups and downs, because that's more realistic, isn't it? That's what more movements in real life are going to be like. So I'm going to have a go at the first. I'm going to have a go at A, C and E, and I want you to have a go at B, D and F. So C to L. C to L. Well, I want to go up and right. That's kind of my path of how I'm going to work it. So I'm going to go up. That is going to be V. And then when I go to the right, that is going to be U. Both positive, because I'm going in the same direction that they've stated they are. So my vector C to L, I can't just go in this diagonal line. You've got to pretend that everywhere that isn't a line that we have a vector for is kind of like crocodile infested water, and if you walk across it, you're going to get eaten. So we've got to walk along the paths. So you've got to go up V and then to U. So that is going to be V plus U. So why don't you pause the video and have a go at BL now? B. Finding BL. Okay, hopefully you've had a go at that. I'm going to do this in a different colour. So B to L is going to be here to here. So I need to go 2 up and 2 to the right. So I'm going to go up this. That is going to be the vector V. And then when I go 2 to the right, that is going to be the vector U, just this one movement, and then U again, this one movement. So here we should get V plus 2U. Okay, my turn to have a go at GN. So G to N. Again, I'm going to get a different colour for this. I might wipe my screen halfway through if it gets a bit too messy. But G to N. So what I'm doing is I'm going up by 2. And I know up by 2 is my vector V. And I'm going 1 to the left. Well, I know 1 to the right is U, so 1 to the left is minus U. So that vector would be V subtract U. Just following the path V minus U. Okay, pause the video, have a go at OE. So O is going to be here, and E is down there. Okay, hopefully you've had a go at that. I know I've just covered that up, so if not, you can pause it now and have a go. So, hopefully you've had a go at that now. O to E. I'm going to clean my screen after this one. So O to E. Well, I want to go 1, 2 to the left. And I know going 1 to the left is minus U. And then I need to go 1, 2 down. So instead of that being, that's the kind of the movement of V, but V wants us to go up by 2. So going down by 2 is going to be minus V. So well done if you got minus 2U minus V. You can always, I've not said this before, but you can go down and then across. Obviously I'm doing it my way. You can go down then across. You can even go across one then down then across. They'll all get you to the exact same answer. I mean, that'll be minus V minus 2U, which is the same as this. That'll be minus U minus V minus U. That'll be minus 2U minus V. Okay. I'm going to erase my stuff. and we're going to have a go at the final 2. Perfect. Okay, so k to n. Let's find k, and let's find n. So I want to go up by 1. Up by 1 is half of this movement, so that is going to be half v. And then I want to go left by 1. That is going to be minus u, because u is to the right, I'm going to the left. So this is going to be half v minus u. Have a go at HQ for me, F. So H is here, and Q is right in the top left. So have a go at finding that movement for me. Okay, hopefully you've had a good go at that, and I'm going to do this one in green. So I'm planning on probably going all the way to the top and then all the way to the left. So I've done a movement of V here, and then this one block is going to be a movement of half V. So overall I've done 1.5 V. And then I'm going to go 1U, 2U, 3U, but that's not just U, they're all going to be minuses, aren't they, because I'm going to the left. So let's retrace that. I've gone V, 1.5 V, so 1.5 V, minus U, minus U, minus U, which is minus 3U. Or you can write 3 over 2V minus 3U. I'd probably say that second one is my favourite. I like top-heavy fractions. But I just think it looks neater. Okay, hopefully you've had a good go at that and understood it. We're going to look at some triangles now. So, again, I've got a question that I'm going to do, and then I've got a question that you're going to do. So I'm going to do this whole slide. Completely same concept as last time, but just less of a grid and more of a possibly realistic thing. You want to get between these 2 points, but the paths take you all the way around the edges. I like to think of a theme park with this. You can't just walk straight across Rita Queen of Speed, you've got to go all the way around it. So work out QR in terms of A. Well, QR is from here to here. So let's trace my steps of the paths I can take. We can only take paths that have arrows on them. So I'm going to go here, and then I'm going to go here. So I'm doing minus A, because I'm going back against the arrow, and then I'm doing positive B. So QR is going to be minus A plus B, or you can write it as B minus A. Really doesn't matter. I just like to write it in the way that I walk the path, because I think it's easier to form it. So I know I did minus A, I'm going to write that down. Then I've done a positive B, so I'm going to write that down. So how about RQ? Well, you can see on the thing that it's kind of just doing the opposite. So RQ is going here, then here. We can't do any magic trick of walking across this path this time. So in this case, I've gone minus B, because I've gone against the path of B, and then I've gone A, and I've followed the path, so it's a positive A. So RQ equals to minus B plus A. Or we can write it as A minus B if you want your signs to look a bit nicer. But again, I think that's a really good answer, because it shows the exact path that I would have taken in the order I would have taken it. And then M is the midpoint of QR. So midpoint just means it's halfway. Means it's halfway between. And if something's halfway between, well, it's going to be half the journey of QR. Yeah? Because QR is going to take us all the way from here to here. If we do half of that journey, it's going to take us this distance. We'll just do like a half journey there and a half journey there. You can see that kind of makes up. You can imagine that in your head, doing half of A, half of minus A, and then half of that. So what would QM be? Well, QM is going to be half the journey of QR. That's some weird notation here. First time you'll have seen stuff like this, so just take a second to kind of take that in and I'll explain it. That is just saying the vector qm is going to be half the journey of what I have called qr, this whole thing, or going all the way around it. And then where I've put qr, I'm going to change to that same green in a second. So I can say, well, that equals to half of, well, qr was minus a plus b. Yeah, you can see I've substituted this in to where this was. So then I can leave it like that, to be honest. That's a completely fine answer with a bracket. Or I can say, well, if I expand this bracket, just treat these like x's and y's. If we had minus x, you'd say, well, that is minus a half a plus a half b. So either of them are acceptable as an answer. There's nothing wrong with leaving it in a bracket. Expanding it might be helpful if you've got something later on in a question where you've got to use it again. But just to reiterate that, if it's just a midpoint, it just means it's half the journey of the full thing, so a QR in this case. And generally in questions you'll have found that QR path before you're asked to find the halfway path. Also, you could have written that as a half b subtract a half a. Okay, I want you to have a go at this question, but I'm just going to point out a few pointers. So, AB is parallel to BC. That just means AB and DC aren't going to meet. DC is 3 lots of AB. So that means it's 3 AB is U. So 3U. So DC, that whole journey on the bottom, is 3U. And we've got our point, our midpoint, B to C. And that is a midpoint of BC. So bang in the middle of these two. Okay, see if you can answer these questions for me, and I'm going to go through it in a couple seconds. 3, 2, 1, and back. So let's have a go at what AC is. Well, AC, I'm going to go along V, so V, and then I'm going to go along 3U, so plus 3U, so V plus 3U. Could be tempted to go this path, but there's actually no path to get me from B to C. That's where our crocodile-infested water is at the moment. We can't walk across there. B to C, again, so I said we can't do that. We've got to go all the way round. I know it seems a bit, you'd be a bit annoyed. It's a road near my house that's a one-way going this way. I live there and I've got to go all the way around, and it annoys me every single time I drive past it. So I've got to go minus U. So equals to minus U. Then I'm going to go plus V. Then I'm going to do, get to here, then I'm going to go plus 3U. And that's taken me from B to C. I've gone B to A, then A to D, then D to C. We can collect these terms just like it's algebra, so these U's, I can collect them. I've got a minus U and a 3U. That is going to be 2U plus V. Okay, so you can kind of imagine what this path is going to be. I'm going to go a little bit this way and then back down. That's what 1U, 2U, and then a V would be. You can see it kind of works. B to M. So B to M is half of what B to C is, because it's the midpoint of B to C. So we've just found B to C, it's here. So this is going to be half of 2U plus V. So that is going to be U plus a half V, expanding that bracket out. And then M to D. Well, a little bit of a harder one. Let's have a think. Well, what paths could we do? We know what MB is. We know what BM is. So if we want to go from M to B, we do the negative of all of this, and then we can work our way from B to A and then A to D. Probably the better way to do it is, I know that that vector there, B to M, because it's a midpoint, it's going to be exactly the same as M to C. So I know B to M equals m to c. So the path I'm actually going to take in orange, the path I'm actually going to take to get from m to d is from m to c, and then I'm going to go back from c to d. That's just less working for me to do. I don't have to take this negative and I don't have to add on 2 more things. So I'm going to take the path of m to c, and then I'm going to add on the path of c to d. And c to d is the opposite, so the negative of d to c, which we know is 3u. So this is going to be u plus a half v. That's going to get me down from m to c. Then I'm going to subtract 3u because I've gone this path here. I just need to collect this term, so u minus 3u is minus 2u, and then there's no other v's to collect. So it's like this. That is quite a hard question, that last one, and the third one as well, and C. So really, really well done if you've got that, and well done if you're just starting to understand it after I've gone through. Okay, and then final question. I'm not going to do that last slide. Final question that we can do together. If you're feeling confident, you can have a go. I made you have a go at the last slide instead. So only if you want to, or you can just wait for me to go through this. So, A to C. Well, actually, I'm jumping way in. They haven't labelled the diagram for us. This is why I had this question on. So A to B is P. So that is the vector P. A to D is Q. And D to C is R. So these are the 3 paths we're allowed to walk on. We're not allowed to walk on this path, and this path in the middle is also shark infested. Or crocodile infested, I forgot what I was saying earlier. And EC, E is the midpoint of this line, so this bit here, A to E and E to C are equal. So I'm going to write that down here. A to E equals E to C. So let's find A to C. If I'm going from A to C, that's here to here, I'm going to go up Q, and then I'm going to go along R as well. So A to C is going to be Q plus R. Different colour time. So B to C. Well, B to C, it would be nice and easy if I could do that, but I can't. There's no arrow on it. So I need to go back along P, so that is going to be minus P. And then I'm going to go the correct way on Q, and the correct way on R. So my path is minus P plus Q plus R, and you can write that in any order as long as your negative is still with P. And then A to E, so the harder one because it's a midpoint. Well, A to E, that is half of what A to C would be. And we've just found what A to C is. That is Q plus R. So that is going to be half Q plus R. So half Q plus a half R. You can leave it as that one, you can leave it as that. Then I'm going to do this last slide, but stick around if you want to. It's some really interesting questions here, and this is kind of the next step with vectors, this one at the bottom. So true or false? AB is equal to CB. It's an isosceles triangle. AB is equal to CB. Well, you might think true. This is true. Because when we don't have an arrow on top of it, that just means the length. And yes, AB is the same length as CB. But this actual question here is false because they are vectors. The vector A to B is not the same as C to B. They go in opposite directions. A vector that's same as A to B would look like this. You can see it's going up and to the right, that's going up and to the right. So that's kind of a tricky thing of really pointing out between the notation with vectors. Okay, the second one. M is the midpoint of AB. So AM equals to half of AB. And B to A, well, this is a tricky one again. If that equals half of AB, that also equals half of AB. So if I'm going to, or we can also say that that equals to AM, the same thing, AM equals to this. And because it's a midpoint, MB also is the same as AM. So they're the two things I'm going to take notice of. So if I want to go back along here from B to A, I'm going to do minus AM and minus AM. So that is minus 2 lots of AM. That's quite a tough one to see. And then this one. So I'm going to go to a different colour for this. This is split such that Bn is in the ratio 1 to 2. We don't like ratios when we're talking about this. We want to convert that to a fraction. So what would the fraction of this top bit be? Well, it's 1 out of the total amount of 3 parts. So that is a third of this path. And this is 2/3 of the total of BC. So that's really important to know. So Bn equals 1/3 of the total of the line B to C, and N to C equals 2/3 of the total of B to C. And that's how these vector questions can start getting harder. By instead of having midpoints, you have to deal with some fractions like this, and they like to give it you in ratios, because that's a nice way to represent stuff, but it's not a nice way to do algebraic working. We want to convert that to fractions. But I'm going to leave it there for today. So thank you very much if you stuck around right till the end. And that's all I have for you today.